All right, hello and welcome back, everybody. Today we're going to be looking through the first of several SAC preparation tasks that I'm getting you to do in the lead up to the investigation. So, this first question here relates to determining the rule for a parabola. As we know, whenever we have a parabola, that is a quadratic equation, so it's a shape that looks like that or like that. And it has the general rule for a quadratic equation: y equals ax squared plus bx plus c, where a, b, and c are real values that we need to find. And we know that this parabola passes through the points that have been given to us here. So the question is, how do we go about solving a problem like this? So essentially, whenever we have three unknowns, and this is always a rule, whenever we have three unknowns, a, b, and c, we need three pieces of information to solve for those unknowns. And specifically, all you have to do here to solve this problem is to basically substitute each of those values into the equation. So for example, sub in -1, 2 into this equation here, into y equals ax squared plus bx plus c. And then we're going to get 2 is equal to a times -1 plus b times -1 plus c. And that simplifies down to -a minus b plus c. So that gives us this equation here. That's using the first piece of information. And we're going to do this with each of the points. And then we're going to create a system of equations where we have three equations and three unknowns, and then we could use our CAS calculator to find those unknowns. So next up, we can go ahead and go sub in 1, 3 into above, just as before. So this is going to give us what? So we're going to get y, well, we're going to replace y with 3, so this will become 3 is equal to a times 1 squared plus b times 1 plus c. When we sub them into this equation here, that gives us a plus b plus c is equal to 3. Fantastic. So that's our second equation. So you can imagine this is equation 1 here, this is equation 2 here, and we'll just do the same thing one last time. We're going to take the point 1 half 0, and we're going to sub it into y equals ax squared plus bx plus c. So this is going to give us 0 is equal to a times a half plus, a half squared plus b times a half plus c. Now a half squared, that's going to be 1 over 4, a plus b plus c, and we know that's equal to 0. Okay, so there are our three equations. And what we would then do is we would take these three equations, so we'd go onto our CAS calculator. We're going to solve the system of equations that we've developed here. So we'll just list out the equations one more time. We have a equals -a minus b plus c. The second one was 3 equals a plus b plus c. And then the third one was 0 is equal to 1 over 4 a plus b plus c. And we want to solve this for a, b, and c. So let's go ahead and do that. We'll bring up the trusty CAS calculator here and just plug in those equations. So the technique you're going to use here is you're going to go to the math screen here, math 1. We locate this button like this, and we can hit it one more time. If we click that button again, it adds a third line for a third equation, and we can just type in those three equations. So we have 2 is equal to -a minus b plus c. 3 is equal to a plus b plus c, and 0 is equal to 1 on 4 a plus b plus c. Solving for a, b, and c, hit enter. There are the potential values. It's also really important to just double check that this actually does satisfy what we wanted it to satisfy. So we can just type in the equation with these as our a, b, and c. So a is equal to 4, so we have 4x squared minus 3.5x plus 2.5. And let's just look at this. Does this pass through the points that we want it to? Well, it should pass through -1, 2. And it doesn't, so that's a bit of an issue. Does it pass through 1, 3? Yes, and it passes through 1 half 0. It does not, so we must have made a mistake somewhere along the lines here. So let's see if we can spot our mistake. It looks like equation 2 is good because that point lay on the line. So let's see if we can work backwards and figure out what went wrong. Okay, so over here, I forgot the square, but I guess this is possibly a good little troubleshooting exercise for us. So that should be a plus there. That means this should be a plus over here. And this other equation here was looking good, I think, and we forgot the half there as well. Okay, well, that's a bit embarrassing, but that's all good. That's how we can kind of identify what went wrong. So we can see there, it's always good to double check that your solution actually does work. So I think that's completely a bad thing that you can see this happening here. So we'll just plug in each of those values. We've got 1/2. Okay, let's try this one. And I want to get an answer that is in a fractional form, so I'm going to hit standard. And these are supposedly the A, B, and C values. So let's check to make sure that they are correct. And fingers crossed we get it right this time. That is plus 1/2x minus 7/6. There we go. And let's double check if our points line up. So we had that guy, we had 1, 3, and we had 1/2, 0. And indeed, they do all lie on the graph. So that's fantastic. So we found our first solution. Now, I wanted to show you that there is actually a better way of doing this on the CAS calculator. So something that would be fantastic for you to learn about is the define function. So how to access this is you can go action transformation. Let's see if we can locate it. I think it's command. Yes, action command define. Get here. You're then going to type in function, so you can locate f here. F of x is equal to, and I'm going to define x as the thing that we're trying to solve, ax squared plus bx plus c. Okay, now look what happens. If I plug in a letter, so let's say if I plug in -1, it substitutes in -1 into that equation, and it gives me the first setup that I had here. If I substitute -1 into the equation, I get a minus b plus c. See that? Now, we can actually use this definition form in our system of simultaneous equations. So if I click this button here and I click it again, just like we did before, I don't actually have to do anything by hand. I can do it all on the CAS calculator. So for example, I could say, using this first condition, subbing in -1, 2. This is the same as saying the function with an input of -2 will spit out a value of 2. If I do the same thing here, we have function with an input of 1 splits out a value of 3. Function with an input of 1/2 spits out a value of 0. And if I solve for A, B, and C, I just get that answer that we arrived at immediately, and that's without showing any working out. Fantastic. So let's now apply this method I've just shown you to the second question, and let's see if we get the right answer. So the question says, determine the rule for the parabola that passes through this point and has a stationary point at x equals 2 and a gradient of 4 when x equals -1. Okay, it's a bit different to last time, but let's just start out. We know that it's a parabola, okay? So we're going to say, let's let f of x equal ax squared plus bx plus c. And we know that it has this form because it is a parabola. So our goal is to find a, b, and c. And again, we've been given 3 pieces of information. The first piece of information states that the function with an input of 1/3 is equal to -1/2. That's what it means for the point to exist on the equation. Fantastic. What does it mean for it to have a stationary point at x equals 2? Well, let's remember a stationary point means that the derivative function is equal to 0. That's what a stationary point is. So that's like a maximum or a minimum or a stationary point of inflection, which looks like this. So let's list this out. So we have our second piece of information, which is that the function, so the derivative function, when x equals 2 is equal to 0. And our third piece of information we've been given is that the gradient is 4 when x equals -1. So this means that the derivative at x equals -1 is equal to 4. So that means that f dash -1 is equal to 4. These are our 3 pieces of information. Now let's see if we can just do this in the CAS calculator straight up. So first up, we're going to get rid of what we had on the last line. We're going to go back to this point here where we have, we're just going to define f of x. So you would do the same thing as before. We go action, commands, define f of x is equal to what we want it to be. Then we're going to define another function. We want the derivative function. So we're going to go command define, and we're going to define, let's say, g of x is equal to, well, what would be g of x? Well, first up, let's see if we can know how to do something. If you go to Math 2, you can calculate the derivative. Of course, you could do this by hand, but it's good to know. We go d dx. We can take this line from above. You can go edit, copy, edit, paste. There you go. That's our derivative function. And if we just define that, if I go action commands define this as equal to, say, g of x. Now I have two functions. I have the function f of x, which is what we have here, and I'm defining g of x as equal to f dash x for the purpose of using the CAS calculator for this solution. And now I'm just going to go ahead and plug in the initial conditions. So going back to this screen here, I'm going to create a system of equations, and I'm just going to just type in the initial conditions we've got here. So my first condition is that the point 1 over 3 negative a half needs to lie on the graph. My second condition is that the derivative, so remember g is the derivative when x equals 2 is equal to 0, and the derivative when x equals -1 is equal to 4. The gradient is 4. Go A, B, C, and that gives us our solutions. A is equal to -2 over 3, so we have, therefore, y is equal to -2 over 3 x squared plus, what was the second one? We had 8 over 3x plus, so I think the final one was a minus. It was minus 71 over 54. Weird numbers, but you know, it is perfectly expected for these numbers to be a bit wacky. And in fact, on the SAC, you're going to have some wacky looking numbers as well. So don't panic. We just want to check to make sure that this is actually what we're looking for. So we can go ahead and type in this equation. So we have y equals, we'll get rid of those points that we had before. So we have y equals -2 over 3x squared plus 8 over 3x minus 71 over 54. And that gives us this graph here. And we need to just double check those conditions are met. So do we have the point 1 over 3, -1 over 2? Yep, that does seem to lie on the graph. Fantastic. Does it have a stationary point when x equals -2? Well, if we go to when x equals 2, we can see that there is indeed a maximum there. So that is the maximum of the graph. So that means that there's a stationary point there. And then finally, we need to have a gradient of 4 when x equals -1. So kind of hard to tell, but if we were to take the derivative of this graph, we're going to get y is equal to -2 over 3, -4 over 3 times x plus 8 over 3. That would be the graph of the derivative function. And if we look at that derivative function, when x is equal to -1, we have y is equal to 4. So that tells us that the gradient, because this point lies on the graph, -1, 4, because that lies on this derivative graph, then the gradient of our original function, that black one there, must be 4 when x equals -1. And those are our two equations. So we found our two parabolas for questions 1 and 2. Fantastic. All right, we'll pick things up again in this second video just in a couple of minutes. I'll see you guys soon.